Hi, in this video I'm going to go over graphing functions using vertical and horizontal shifts. Now, we all know, or you should know, what graphs look like. This is a linear graph. It's going to be a line, right? You get x squared. You know you're going to have a parabola. X squared plus bx plus c, a in the front of it. You're going to get a parabola or something. And cube root function is going to look like this. But if we know mathematically how these graphs are shifted up and over and down and all around, it'll be faster graphing them. Because then you know where the origin point is, the middle point, the y-intercept for lines, the minimum or the maximum of parabolas, right? And the origin, that middle spot in a cube root function and all sorts of function, also the cubed function, which would be like that. Anyway, so let's start with a simple line. We've got f of x equals 2x, right? And let's just do vertical shift to start, right? So what we do is we take that function, f of x, and let's say we want to shift up, we say plus 2, right? So that gives us 2x plus 2. Simple, right? Well, we know how to graph that because we know mx plus b, right? Because you've been watching my videos, right? So, y-intercept is positive 2, 1, 2. Slope is 2, so we go up 2 over 1, right? Or down 2 over 1. So our line looks kind of like that. But before, pretty badly drawn line actually. Before the shift though, it was on this. This was our y-intercept, right? Right at the origin, of the Cartesian coordinate system, because there was no b, right? And it was a parallel line to the line we just drew because it has the same slope, right? Not bad. Now, drawings don't have to be perfect, but the dots do. Right? Okay. Easy, right? That is the easy part. The horizontal part is always getting people confused, including me sometimes. How do we shift this horizontally? We already know it goes up and down very easily. We just add or subtract, right? We can subtract 1 and we just go down to here, right? Right there. That's simple. But how do we shift it left and right? Well, we are adding and subtracting. But the thing is we're not adding it like this, like we did before. We're adding it inside the parentheses. We're adding it to the input itself, which gives us 2 times x plus 2. We're substituting. We're taking that input and adding 2 to it before we're multiplying by the slope. You're like, wait, what? That would be changing the b value too, wouldn't it? Because we're using the distributive property. Yes, it would, because when you move a line to the right or to the left, you're changing its vertical y-intercept. It's vertical position as well. So f of x plus 2, which is different from f of x plus 2, would be 2x plus 4, which is also just a shift up, right? Because now our y-intercept is at positive 4, 1, 2, 3, 4, right? And the slope is still the same. 1, 2, 1 over. Okay, right? Like, wait a minute, how is that a horizontal shift? We shifted to the left 2 spots. You see that? When we added 2, shouldn't we shift to the right? Because right is the positive way, right? No, it is not. Not in, well, yes, it is the positive direction. But it's not the way we should shift, because when we add to the input, we're kind of saying that our original input is 2 units less than the original input. So when you add, you go to the left. And when you subtract, you shift to the right. So f of x minus 1 would be a shift to 2x minus 2, right? So 2 times x minus 1, distributive property, right? You would shift it to the right, because now our y-intercept is at negative 2. Right? Something like that. Oh, my terrible drawing skills. As long as the dots are correct, it's fine. Makes sense? This is why I used a line first, so that we can get it straight in our heads what the shift is doing. Now, if I told you to graph a line that was f of x equals, I don't know, 2 times x minus 3 plus minus 2. Where would your origin point be? Because instead of it being at the origin, it's now at positive 3, right? Because it's the opposite of that, but then it's the same. It's the same as that. It's like it's a point. It's giving you a point on your line. And we already know the slope is going to be 2x, or 2, not 2x. This is called point slope form, right? Basically, we're saying that up 3 and over 2 and 2. Actually, what am I doing? Over 3, 1, 2, 3. Down 2, 1, 2. Ugh, sheesh. Didn't have coffee this morning. that is our new origin point, and our slope is still 2. So 2, 1, 1, 1. See how easy that was? I didn't even have to distribute all that. Well, what if we did? Just to check our answer, right? Let's distribute this to see what we get. 2x minus 6, right? Minus 2. 2x minus 8. What's our y-intercept? 1, 2, 3, 4, 6, 7, 8. It should be 8, or minus 8. Let's see. One, two, 1, 2, 1, 2, 1. Yeah. 1, 2, 1. Yeah. I didn't draw it right, but yeah, this is what we just graphed. Isn't that fun? How that worked? All we had was this mess of numbers, and we could just take what we know about the graph already and just shift it, right? Just remember, the horizontal shift is always the opposite of what it is. If it says -3 in there, it's a +3 shift. All right, now let's just do the same thing, but with parabolas. As we know, function f of x equals x squared is a parabola, right? With that minimum at the origin, right? So if we wanted to shift it up, we would say x squared plus 2, right? And the origin would be just shifted up 2, right? And if we wanted to shift it to the left, we would say x plus 3, quantity squared, right? Which means it would go 1, 2, 3. So we're adding, right? For the horizontal shifts, it's always the opposite, going to the left, right? So now, no matter what we do to those two values, you know exactly where the origin point is and how to graph it, right? So let's say x minus 2 squared plus, nah, let's not do plus, let's do minus 1. Okay. Let's graph it. Origin point is at +2, -1. 1, 2, -1. And now it's a parabola, so we just make that U shape, right? No, we got to make sure it's right. Well, for any parabola, 1 squared would be what? 1. So over 1 up 1, over 1 up 1. 2 squared would be 4. So over another 1 up 3, right? Because it would be from this, pretending that this is the origin point now. And this is +1, so it'll be 2, 3, 4. All right. And kind of mirror that on the other side here. That are the points for the parabola that has been shifted over 2 and down 1. See how that works? Not so bad, right? Same goes for h of x equals x cubed. If you remember what the x cubed basic function looks like, something like that, right? Because the further you get positive, the faster it goes up. And the more you get negative, it does the same thing because, I mean, because when you multiply a negative by itself 3 times, you keep the negative, so it goes down instead of up, right? So we shift that by, adding 1, cubing it, and then adding, I don't know, another 1. Then it's just going to go left 1 over 1, right? Because the horizontal shift is always the opposite, negative 1, and then up 1. Opposite, not opposite. Opposite, same. So up 1 over 1, that same origin point does the same thing both directions. And that is how you graph using vertical and horizontal shifts. Thank you for watching.